Welcome to The Explainer, everyone. I am so incredibly excited to have all our Focused Learner primary school students joining us today. We are jumping right into a journey, literally diving into the very heart of a computer to uncover exactly how this amazing technology works.
So, have you ever wondered what's actually happening inside that glowing screen when you play a game or type a message? It seems like magic, doesn't it? Well, today we are going to crack the code and figure it all out. And hey, pay close attention because I've got a really fun pop quiz waiting for you at the very end.
All right, here's our roadmap for the Explainer. First up, we'll meet the digital helper. Then, we'll look at the 3 magic steps: input, process, and output. After that, we'll decode hardware versus software, explore brains, memory, and storage, and then zoom out to the OS and the internet. And, of course, we'll wrap up with that pop quiz.
Okay, section 1. Let's meet the digital helper.
Before we get into all the moving pieces, we really need to understand what this incredible, super fast assistant actually is. Basically, a computer is a smart electronic machine. But, what does that actually mean for us? It means it takes information, works on it, stores it safely, and then gives you results, all to make our work so much faster. It's a helper that saves us tons of time, holds huge amounts of data, like your favorite photos and games, and connects us with people everywhere.
Now, let's dive into this for a second. We often compare computers to brains, right? But there are some absolutely huge differences. Humans think naturally, and we feel emotions. You can laugh at a joke or feel super happy when you win a game. A computer, though, it cannot feel anything, and it cannot think on its own. No way! It absolutely needs instructions to do anything. But once you give it those instructions, it works incredibly fast, way faster than we ever could.
Moving right along to section 2, input, process, and output.
To really understand how a computer follows instructions, I want you to imagine stepping into a busy, magical kitchen. This 3-step process is exactly how a computer works, and our kitchen analogy makes it super easy to grasp. Step 1 is input. This is when we give the computer data. In our kitchen, this is like gathering your raw ingredients: the flour, the sugar, the eggs. Step 2 is the process. The computer works on that data. This is the chef actually mixing the batter and baking it in the oven. And finally, step 3 is the output, the delicious, fully baked cake ready to eat. So how exactly do we hand over those raw ingredients? Well, we use input devices, things like your keyboard, mouse, microphone, scanner, and webcam. Whenever you type a letter, or click a button, or speak into a mic, these devices act just like your hands, passing the raw data straight into the computer's kitchen so the chef can get to work. On the flip side, we have our output devices: the monitor, printer, speakers, and projector. These are the devices that serve you the finished cake. When the computer is totally done working, it shows you the final result through these devices. You see the picture on the monitor, you hear the music through the speakers, or you grab a printed drawing right from the printer.
All right, section 3, hardware versus software. Now, what's really interesting about this is how these 2 major categories make all those input and output devices actually function. Without both of them, our digital kitchen simply would not work. Hardware includes the parts of the computer you can physically touch: the monitor, the keyboard, the mouse, the actual case itself. Going back to our analogy, hardware represents the physical kitchen: the metal pots, the heavy pans, the oven. Software, on the other hand, well, those are the programs, like Windows, your video games, or apps. You can't hold software in your hand. It's literally the written recipe that tells the chef exactly what to do.
Next up, section 4, brains, memory, and storage.
So, we've talked about the kitchen, the pots, and the recipes. But who exactly is doing the cooking inside this machine? Meet the head chef, the CPU, which stands for Central Processing Unit. The CPU is known as the brain of the computer because it does all the main work in processing. Whenever you ask the computer to do something, the CPU is that busy chef chopping, mixing, and baking at lightning speed to get your result ready. And our head chef actually has 3 specific tools to get the job done. The control unit is kind of like the chef shouting out orders and controlling all the activities. The ALU, which stands for Arithmetic Logic Unit, is the calculator. It does all the math required for the recipe. And finally, the registers. These are like the chef's apron pockets, very small, super fast storage spots to hold tools they need right that exact second.
And this brilliantly illustrates how memory works. Think of a computer's memory like a giant library. The storage, like your hard disk or a USB drive, is the permanent bookshelf. It keeps all your files, photos, and books safe forever
even when the power is completely turned off. But RAM? RAM is your small reading desk. It's temporary memory. It helps you work fast right now. But when you turn off the computer, the reading desk gets completely cleared off. It forgets everything.
Okay, Section 5, Operating Systems and the Internet.
We've looked at all the tiny pieces, but how does everything stay organized and connected? Well, the operating system is the main software. It's the ultimate manager of the computer. Examples include Windows, Linux, Mac OS, or Android on your phone. This manager helps you open apps, keeps track of your files, talks to your mouse, and makes absolutely sure the entire computer runs smoothly without crashing.
And what happens when our computer wants to talk to someone else's computer? It uses the internet. The internet is a massive, invisible web that connects computers all over the entire globe. It's exactly because of the internet that we can browse websites, watch fun videos, take online classes, and chat with our friends no matter where they live.
All right, Section 6. Let's take a pop quiz.
Okay, my focused learners, it is time to see how well you remember our magical digital kitchen. Get ready to shout out the answers. Here is your very first question. Is a keyboard an input or an output device? Think about it for a second. Are you using the keyboard to hand over raw ingredients to the kitchen? Or is the keyboard serving you the final baked cake?
If you said input, you are absolutely correct. Great job! You use the keyboard to type letters and commands, which means you are putting data directly into the computer.
Okay, here is question number 2. What happens to RAM when you turn off the power? Think back to our library analogy. Do you remember the difference between the big, permanent bookshelf and the temporary little reading desk? It forgets everything because RAM is temporary memory. The very moment the power goes out, the reading desk is cleared off. And that is exactly why we need permanent storage, like a hard disk, to make sure our important homework and fun photos are kept safe for sure.
You all did amazingly well on that quiz today. So knowing how this magic machine actually works, how will you use your digital helper today? Every single time you click a mouse, watch a video, or type a word, I want you to picture the amazing hardware, the clever software recipes, and that busy head chef CPU doing all the cooking right inside the box. Thank you so much for joining me for this explainer. Keep being curious, and I will see you next time.